Hi class, how are you today? I've had enough of this. If you're not rational, we're not going to be able to solve our problems. The learning target for today is to be able to solve rational equations. You're stale? You're 3 if you can solve rational expressions. That should say equations. You can solve rational equations. There, that's better. You're a 2 if you can solve rational equations that don't require factoring. You're a 1 if you can solve rational equations with monomials in the denominators. And you're a 0 if you cannot solve any rational equations. Alright, let's get started. Alright, to solve rational equations, it's pretty similar to what we had to do to solve... Alright, to solve rational equations, it's pretty much what we had to do when we added or subtracted rational expressions. We need common denominators, but we need common denominators all the way through. So every fraction has to have a common denominator. So in this first one, we have k, we have 3k, and we have 6k squared. So the common denominator would be 6k squared. So we need to multiply the top and bottom of the first one by 2k. And we need to multiply the top and bottom of the second one by 6k. And so that's going to give us 1 over 6k squared equals 2k over 6k squared minus 6k over 6k squared. And now all of these have the same denominators. So the fun thing about this is now that everything has the same denominators, all we care about is the numerator. So now we could rewrite this as 1 equals 2k minus 6k. And so 2k minus 6k is negative 4k, so 1 equals negative 4k. Now we divide both sides by negative 4. And k is equal to negative 1/4. Remember, can't have the negative in the denominator, it's either in the numerator or in front of the fraction. And that's our answer. We do have to check to make sure that the answer isn't one of the excluded values. So, negative 1/4, we need to see if we plug that back in, would we get 0 for a denominator? That wouldn't be the case here, because if we plugged negative 1/4 back in, we would end up not with 0, right? Because only 0 for the denominators would give us a denominator of 0 in this case. Alright, for the second one, now we have some binomials. With the binomials, we're going to have to factor in a way, at least to know possibly what our common denominator would be. So we have v squared minus 5v, which is the same thing as saying v times v minus 5. So that means we're going to have to multiply the first fraction, top and bottom, by v minus 5. So times v minus 5 times v minus 5. We do that out, we get v minus 5 over v squared minus 5v plus 3v plus 12 over v squared minus 5v equals 7v minus 56 over v squared minus 5v. So all the way through, same denominators. Now we can just get rid of the denominators. So v minus 5 plus 3v plus 12 equals 7v minus 56. Combine like terms on the left. That'll give us 4v plus 7 equals 7v minus 56. Subtract 4v from both sides. Add 56 to both sides. And that will give us 63 equals 3v. Divide both sides by 3. And that will give us v equals 21. And again, we do need to make sure that that isn't one of the excluded values, but the excluded values would be 0 and 5. 21 is not 0 or 5, so that works, and that is good. Alright, so on this next one, we have no like denominators. So our like denominator, our common denominator, is going to have to be n plus 8 times n plus 1. So we're going to have to multiply n plus 1 on the first one, and then n plus 8 on the second one, and then on the third one, rather, because then the 1 is going to multiply by both, because 1 as a fraction is 1 over 1, and so I don't have room to write that, but that's going to have to multiply on top and bottom by n plus 1 and n plus 8. So our denominator for all of them is going to be n plus 1 times n plus 8, which will be n squared plus 9n plus 8. And the numerator of this first one will be n squared plus 6n plus 5. Remember, when you're multiplying those, you need to multiply everything on the left by everything on the right. So you multiply that all the way through and you get those. The 1 is just going to turn into n squared plus 9n plus 8 over n squared plus 9n plus 8, and then plus 6n plus 48 over n squared plus 9n plus 8. All the denominators are the same, so we can just make this an equation with no fractions. So n squared plus 6n plus 5 equals n squared plus 9n plus 8 plus 6n plus 48. Combine like terms on the right. The left stays the same. The right becomes n squared plus 14n plus 56. We can subtract n squared from both sides, and that'll actually just get rid of the n squareds. Then bring the n's together. I'll subtract 6n from both sides. And so then I will subtract 56 from both sides. And that will leave me with negative 51 is equal to 8n. Divide both sides by 8. And n is equal to negative 51 over 8. Alright, and just like before, we have to check the excluded values, but the excluded values would be negative 1 and negative 8, neither of which are negative 51 over 8. Alright, and then for this last one, we've got n cubed plus 5n squared, which if you factor out an n squared, you'll see is n plus 5. So all we need to do is multiply the first one, or the second one rather, by n squared. and we multiply the second one, or the third one rather, by n plus 5. So then you're going to have 5 over n cubed plus 5n squared, because that doesn't change. Nothing changed about that. We'll have 4n squared over n cubed plus 5n squared, and then n plus 5 over n cubed plus 5n squared. Again, denominators all go away, so 5 is equal to 4n squared plus n plus 5. So we can subtract 5 from both sides, and that'll give us 0 equals 4n squared plus n. So we can factor out an n. So 0 equals n times 4n plus 1. And now we can split that into two equations. So I'm going to switch it over, so we've got n equals 0, and we've got 4n plus 1 equals 0. Don't forget, if you factor out an n, that's still something you need to split up. So n equals 0, that's one of your solutions. So then we have 4n plus 1 equals 0, subtract 1 from both sides, and that will give us 4n equals negative 1, divide both sides by 4, and that will give us n equals negative 1/4. Now, once again, we want to check our answers, and we have two answers at this time. So we want to check both of them to see if any of them are our excluded values. Well, our factors in the denominator were n and n plus 5. So one excluded value was negative 5, but the other is 0. Because if we had 0 in the denominator, right here, if we had 0 in the denominator, we would end up with 1 over 0. And that doesn't make sense. So the n equals 0 actually is not one of our solutions. So the only solution is the n equals negative 1/4. Alright, now time for the sponge activity. I want you to solve each equation. On number 1, I want you to solve 1 over sits x squared plus 1 over sits x equals 1 over x squared. And on number 2, I want you to solve x minus 2 over x plus 3 minus 1 equals 3 over x plus 2. Alright, that's it for this lesson. Once again, please make sure to take notes in the entire video. Attempt the sponge activity, take a picture of everything, submit it all to Google Classroom, and have a good night.